Hi everyone, today I'm going to be demonstrating how to conduct the unsupervised classification and the supervised classification. The first step is stack the images. We use the band composite tool to stack the layers and create a false color imagery. Then we input band 2 to 7, which are corresponding to RGB, NIR, and SWIR in Landsat 8. If we use Landsat 5, we'll stack band 1 to 5 instead of 2 to 7 according to the spectral regions. Once we finish adding all the layers, we save it to an appropriate name and save as a TIFF file. This step usually takes longer time to generate the image. While we are waiting for the process to be finished, I will show you the one that I already created before. This is what it looks like when it finished. We can change it to false color composite with red to band 4, green to band 3, and blue to band 2. Let's move on to the second step. We need to clip the image into the study area. In this step, we'll use the image analysis tool. The image analysis tool is under Windows on the top bar. Click on it and you will see a pop-up window. Then inside the pop-up window, select the stack file on the top and then click on clip icon under the processing section. Then you can see a new TIFF file is created on the left-hand window. This new file only contains our study area and excluded other unnecessary areas. We need to save the file again as an image file, since the TIFF file sometimes will produce an unclassified area randomly during the classification step. We change the file type to image and assign a name for it. Now we are done for the basic steps. Let's move on to the unsupervised classification. Firstly, open the clip image that we just created. Then we select raster, unsupervised, and unsupervised classification. We need to make sure that the input file and output file are images. Next, assign the location and the name for the new output file. Then we'll set the number of classes to 6 classes, and the method is k-means. We click OK and wait until the processing is done. Once it's finished, we open the image that is located in Recent. We can see here is the classified map. The next step is to change the color and the class names. We right-click on the image and select Open Attribute Table. Then we can refer to Google Maps to identify the different classes. We can see that Class 1 is Water, so we change the color to blue and rename it to Class 1 Water. Let's start identifying the Class 2. We can uncheck the layer to identify the class. I think it is residential area. Let's double check with the Google Maps. Zooming into the left corner area, we can see houses and the residential buildings. So now let's change the class name in Erdas. We can change the class name to Class 2 Residential and leave the color default. Let's move on to Class 3. We can tell that Class 3 is vegetation, either urban forest or grassland, but we can't identify them clearly. So let's check the land cover in Google Maps. We can choose a location. I will choose the area located at the mouth of the Credit River. Then zoom into the exactly same location on the Google Maps. We can see the main landscape is urban forest. Once we identify the correct land cover, we go back to Erdas and change the name and color. We change the color to dark green and name to Class 3 Urban Forest. So repeat the same steps and change the color and the name for all 6 classes. So here is what it looks like when it finished. The 6 classes are water, residential, urban forest, grassland, urban, and barren land. Lastly, close the tab and remember to save the changes. So now we are done for the unsupervised classification step. Let's move on to the supervised classification. Now let's move on to the supervised classification. Firstly, remember to remove the unsupervised image that we just created. Now let's move on to the process. Under the same raster tab, click Supervised. And instead of using supervised classification, we'll select Signature Editor first. The Signature Editor tool allows us to create the training size for each land cover. When the Signature Editor window pops up, we can move on to the next step. The next step is selecting the polygons for each land cover. Then we click on Drawings on the top bar and select Polygons. This step is for creating the training size. Typically, we do 3 to 5 sites for each land cover, but for this demonstration, I will only do 3 for now. Let's zoom into the study area. Firstly, I'm going to select the training size for water. In water area, draw a polygon that contains water land cover. Then open the Signature Editor window and click Create New Signature. We can see the pixel values of the polygons are being added into the table, and then change the name to Water1. Then we create another polygon in the water area, and change the name to Water2. Repeat the same step and create a third polygon in the water area, and name it as Water3. Once we created all of the training sites, we merge them into one class by selecting the Merge Signatures in the top bar. Then we change the name to Class 1 Water. Next, remember to delete the polygons that we just created previously. Now, let's move on to another land cover, and I will choose grassland. In this step, we are using Google Maps as a reference. Try to find a grassland area in Google Maps. Let's zoom into this area. We can see it is a golf park and is part of the grassland. Now let's move back to Erdas. We find the exactly same location on the image and zoom into the area. We can see here is a grassland. And then we draw a polygon in this area and add into the Signature Editor. Remember to change the name to Grassland 1. Then we try to find the second grassland area in the image. Let's look at this area, the rectangular shaped vegetation. Go back to Google Maps. We find the same location, the rectangular shape. And we can see it is also a grassland. So we move back to Erdas and draw a polygon on the rectangular grassland. Then we add it into the editor and change the name to Grassland 2. For the last one, we can find one in the bare soil area. In Google Maps, let's zoom into the bare soil area. We can see the surrounding vegetations are all grassland. Let's move back to Erdas. We can select any vegetations in the bare soil area. We draw a polygon and add into the Signature Editor. Then change the name to Grassland 3 and merge them together. Next, we set up the name as Class 2 Grassland and delete the previous polygons. Let's move on to the bare soil land cover. We can see all these rectangles are bare soil, and we can just repeat the steps and create the training sites for soils. Once we finish the soil land cover, we are halfway to the success. Repeat these steps and finish the training sites for all the 6 land covers: water, residential, urban forest, grassland, urban, and bare soil. Then we can move on to the next step. This is what it looks like when they finished. Remember to follow the same order as it presents in the unsupervised step. Therefore, we don't need to do an extra recode step. Next, we can conduct the supervised classification. In the signature editor window, click on Classify and the Supervised classification. We give a name for the output file. I will set it to super.image. Then for the parametric rules, change it to the minimum distance. And now we are just waiting until it finished. When it finished, we click Cancel. And then we open the classified image that we just created. We can see this is what it looks like using the supervised method. The last step is to change the color of the classes. We right-click on the image and select Display Attribute Table. In this step, we don't need to change the class name since we already knew the land cover. We only need to change each class to an appropriate color. For water, we can change the color to blue. For residential, we use the default color. Then we set dark green to the urban forest, yellow to the vegetation, beige to the urban, and oranges to the barren land. Now we can close the tab and remember to save it. So this is the final product of the supervised classification. Later on, we will conduct an accuracy assessment based on the two classified images. Above are all my demonstrations. Thanks for watching.